A mass is projected vertically upward with how much speed? The speed that is double of escape speed. So you have to identify correct speed and distance graph. Okay, so let's start from the very basic concept that if you project the same mass from the surface of this planet, which have a radius capital R, with how much speed? With the speed equals to escape speed. So where it will end up? It will go and its kinetic energy will decrease with the passage of time, and it will of course reach infinity, the point where there is a no field strength, there is a no gravity, and at this point its value of g will be zero and its speed will be zero, means its kinetic energy will be zero because that will completely convert into the gravitational potential energy. So in that case, the graph of VR should be something like this, that graph will be more steep and it will be touching the R at some point where the speed will be zero. But if you are throwing an object with how much speed? The speed equals to the two times of escape speed. It means that it will reach the infinity, of course, but at this point, its kinetic energy will not be zero, as well as its speed will also not be zero. That's why the graph in the graph, the speed will not decline as sharply as you see that is depicted in C. That's why the C is not possible. Okay, why B and D are not possible, let us now see mathematically. So according to this question, the speed is equals to two times of escape speed. So that's very simple, that the V is inversely proportional to 1 over R, square root of R. And if you see the graph of this function, that will be exactly like this. So it's not flat line like this horizontal line, it's not a straight line. Okay, so only A is possible because you see that even at this point it is showing us some value of speed. It means that this graph is going too long if you extend it, but at some point it will, as I'm saying, at some point it will touch the x-axis and that point will be infinity.